Our guest today knows a great deal about the electricity in your home. He is the chairman of the Central Electricity Generating Board, Lord Marshall, soon to be chairman of the privatised National Power Company. Walter, in these days of pollution awareness, everybody's talking about renewable energy resources. What contribution can we expect from them?
Well, hydropower can be very important in the world as a whole because there are a lot of mountains and big rivers elsewhere, but we don't have any in this country, so it's not very important here. Solar power is not very important here. Wind power has a chance to make some economic electricity, but in the main it comes down to solely coal, oil and nuclear power.
And so are there plans to expand the nuclear power program?
Yes, we got 15% of our electricity from nuclear power last year, and we expect to be up to 20% before the turn of the century.
There's a great deal of talk about the warming of the atmosphere, the so-called greenhouse effect, the result of emissions of carbon dioxide. Is the electricity generating industry responsible for that?
Well, a lot is from natural causes, and a lot is from burning oil or from coal or burning wood. But yes, the electricity industry has to take a share of responsibility in that. That's one reason for going more rapidly for nuclear power, of course.
Now, as far as efficiency is concerned, energy efficiency, surely we could do a lot by using our electricity more efficiently.
Well, that's very important. Energy conservation is important, but it's not much good talking about energy conservation in the third world. There, they don't have energy in the first place.
Of course, the new superconducting materials are a very interesting discovery. Perhaps they will make at least the efficiency of electricity supply rather better than it's been before. Now, I know you brought a demonstration to show us.
Yes, I have, and it's rather fun. What we have here is some hexagons of the new superconducting material. It's not superconducting now, of course, because it's warm, but it becomes superconducting at minus 150 degrees centigrade.
Pretty cold.
Yes, but we can do it without too much difficulty by using liquid nitrogen. Mm-hmm. And so when we pour liquid nitrogen over that, the hexagons become superconductors, and the little magnet that's sitting just in the middle there will make currents flow inside the hexagons, and the two currents will in effect be another magnet, and the two magnets will repel one another, and the magnet will levitate. So let's pour the liquid nitrogen on. There it is.
Oh yes, that's splendid.
And indeed you can poke it about a little bit. It's quite stable.
And as long as it's cold, these currents will go on flowing for ever and ever, really.
Yeah, yes, the currents in the superconductor flow forever, but of course you've got to keep it cold all the time.
Now, does this mean we can expect to use superconducting materials in our power lines of the future?
Well, I suspect not, because if you have a big current in a line, that makes a big magnetic field of its own, and that in its turn destroys the superconductivity. But you'll be able to use superconductivity in all kinds of electrical devices, and that will help us to conserve energy. And that, of course, is going to be very important in the future.
Now, of course, this is not the first time that you've poured cold water on what looks like a promising idea. I'm told from a very authoritative source there was an occasion a few years ago, an important committee meeting to look at the problems associated with a new power reactor, and you were uncharacteristically silent and sat at one end of the table, and eventually the chairman became uneasy. He'd seen you fiddling with your papers but not doing anything else very much, and he asked you your opinion of the new power reactor. And what did you do?
I said nothing.
The white elephant. And did that represent what your thoughts were about the power reactor at the time?
About that particular one.